So, hello everyone. I'm going to talk briefly about the Nix ecosystem. It's a big system. I don't know how many in here that are familiar with Nix and have been working with Nix today. So some of you might not know how wide and varied selection of utils there are to do different things in the Nix ecosystem. My name is Elis. I live in Stockholm. 14 years of Linux desktop experience, 3 years of NixOS experience, and I have a commit and merge access to Nixpkgs from being in the project for a while. How many here have experience with Nix as in the package manager? About half. Okay, so this is my agenda today. I'm gonna touch on Nixpkgs, Nix, NixOS, and the Nix ecosystem. Before we start, I would like to mention a bit about Nix, because it's easier to get what Nixpkgs is about if you know something about Nix, and the other way around. And Nix is a package manager that builds packages from descriptions, like most package managers, but it's also aiming to be very declarative. You will see more about that. So starting with Nixpkgs. Nixpkgs is a repository that contains all the packages, like the main repository. And it's written in the language Nix, which is a bit confusing when you're new, because we use the word Nix for a lot of different things depending on context. Nixpkgs is also a huge software repository, absolutely huge. At least if you count computers and not like app stores for phones. It's not really the same ballpark. Here we have some stats from Reproducibility that index a lot of package repositories. So you can see here that Nix has 49,000 packages, and in amount of up-to-date packages is 23,000 up-to-date packages. So it's actually one of the biggest repositories with the most up-to-date packages in just numbers, which is quite amazing for a community project. And it's a very active project because it's all hosted on GitHub. So it's quite easy for most people to just come with a drive-by commit, fork something, do a change, and push it back. It's not some obscure thing to join. Most people are there. So just for the past month, we had close to 2,000 merged pull requests and 3,200 new commits on master, which is quite amazing for a community project as well. And Nixpkgs is not a repository for unmaintained software. So if it's a piece of software that is abandoned by upstream, we tend to try to get rid of it, unless too many things depends on it, like Python 2. It will take a while to get rid of, but that's the case for every distribution out there, more or less. So, but that's enough about Nixpkgs. So now we're going over to Nix. I'm gonna mention the project origins, the foundation, the package manager, the store, and generations, like the concept, what generations is, which is part why Nix is so great. The store is also a big reason for that. The project, fairly simple, was started by Elko Dolstra in 2003. It's based on his PhD, and it has grown a lot from there. We have a foundation in the Netherlands. They have on paper at least, the ownership of all core infrastructure. they have an elected board. They host a build farm and the binary cache. So in Nix, we fill the cache to make it easy for people to just download pre-built packages based on the package descriptions. This makes it not as much compiling as it could be otherwise. But it still keeps the flexibility as a source-based distribution could have. And we have the package manager. It aims to be reproducible. But if you know reproducibility, it's quite hard because some programs may do silly things like include the timestamp of the current time in the output of the build. That is not reproducible if I build it tomorrow. It will be different. Include the architecture of the host, like what model of the CPU it is. Well, if I build it on my machine, it's probably not the same as yours. But it's a goal, not a reality yet. But there are multiple distributions working on reproducibility. And Nix is working on it by being declarative, by building things in a sandbox, by requiring the packages to declare which dependencies are needed. So the sandbox only contains exactly what's needed. And that way we come closer to being reproducible. And the ultimate end goal, of course, is to achieve determinism. So we actually know exactly which binary we will get when we do whatever we do, which might be very different from use case to use case. So, and part of the build and how we achieve this is by using the Nix store. The Nix store is very special because we store all the packages side by side in separate directories. And with the Nix store, we can avoid certain problems that exist in most other systems, such as the following ones. In Nix, package conflicts, they don't exist. Version conflicts, they don't exist. And circular dependencies, they don't exist either, because if you would declare one, you wouldn't be able to build it. So it cannot end up in the store anyways. There are hacks for certain things, but because certain dependencies are weird, but it's always been like that on Linux. So that's not a new thing. And using this store that has this example layout, we have a hash. This hash is fake, obviously, but this hash is based on the build instructions of the package. So it's all the build instructions, and all the build instructions of all dependencies of the package are baked into that hash. And then we append the human name and the human version to make it slightly more readable. And then all the dependencies are linked, dynamically linked, to the things on a specific path in the store. And that way we can achieve dependencies that share dependencies, but they don't conflict in versions since they are in different paths. And using this file system layout, we can achieve generations. Generations are hordes of symlinks living inside of the store somewhere that describes system or a package by symlinking the correct things together to a single piece so you can use it. And with generations, we can do things like atomic upgrades, because we can put all the things needed for a desired state into the store and then switch the symlink. And with atomic upgrades, we also have rollbacks. because we can switch back to the older symlinks. This, of course, can come with problems, like if you have a database and the database migrates the format and you try to roll back. Good luck with that. But that's a problem for every distribution. So, yeah, it's not just Nix. But using these superpowers that Nix, the package manager, gives us, they have some very smart people went together to build NixOS, which is a Linux distribution built on Nix and Nixpkgs. The main difference between NixOS and Nix is that NixOS comes with a module system for service configuration. Because if you just use Nix on Ubuntu, you can install packages, but you're not very interested in the full configuration of OpenSSH, because that's quite out of context for just a package manager that delivers binaries. So NixOS has wrappers to create systemd services and to create the configuration files, etc., for all sorts of services there is. This is an example of the OpenSSH configuration. So I enable the daemon and I disable password authentication. And this will give me an OpenSSH server running with the port open and no password authentication. All the configuration is written just with those 2 lines. And then I can do other things like define ciphers or append extra config if I'm not happy with the options available. It will just append it to the file to make it super flexible. And with NixOS, we also get system generations because we have those powers within the Nix store. So we get boot generations. So when you boot the system, you get to choose the generation. And so you have the same configuration, but you can boot into any generation and you can roll back and move forward online as well. You can do whatever you want there. It's very flexible. And you also learn to garbage collect after a while. So this is very powerful, but it's not for everyone because it's a bit different from other systems. Many people have a hard time with the store because it's so different. When I started to learn about using Nix and NixOS, I actually gained a lot of knowledge in debugging Linux overall, because you actually needed the proper tools to look in the right place to find the location of certain files because they are in the store. I don't know the path. It's a hash in the name. But I'm going to switch over a bit to the ecosystem at large because the ecosystem is vast. I'm not going to mention even half of the things I know about. Some of the topics here are different platforms, development environments, language tooling, building and deploying Docker images, and operations using Nix. I'm not going to deep dive in those topics, but I'm going to mention bits of it. So different platforms. Nix as a package manager runs on Linux, Darwin, and early stages to run on FreeBSD. Before it could run on FreeBSD for the Linux emulation, I guess, but it wasn't officially supported in any way. And this makes it possible for a team of developers that want to share things to have the same software across multiple platforms. Sure, some software can have bugs on specific platforms, but that happens regardless if you use Nix or not. Then we have like development environments. Have anyone of you used direnv and Nix shell? Yeah, direnv is very nice. It's developed by a Nix guy. It's not specific to Nix. You create a file, it's called .nvarc, and you put it in a directory. And then in that file, you can run things like setting of environment variables. And when you, with your terminal or editor that happens to have support for DRM, you get those environment variables. And DRM also has integration with Nix shell. So if you have a file, shell.nix in there, you can install dependencies when you enter a directory. I have an example of that. It's this file is a shell.nix. I use it when I'm going to generate a presentation like this. So what I do is I define a custom LaTeX environment, because if you download a full LaTeX, it's huge, about a gigabyte or something to download. I don't need that, because I don't need all the languages. So I define what I need, and I get exactly that, and I can just enter the directory, get my LaTeX environment, and build my presentation. And this is in a Git repository, so if others would clone that, they could build my presentations as well. It's on GitHub as well. So this one is a bit stripped down because I have some more things. But for development, we also have language tooling, like Node to Nix, Poetry to Nix, PyPy to Nix, and Vigo to Nix, which are just a few of the 2 Nix tools. There's more. So you can convert dependencies for projects to Nix code to be able to deploy different languages with Nix, because it needs to declare which dependencies to download with hashes and all that to be declarative. There's loads of those. We also use them extensively to package certain bits of software within Nixpkgs. Because of some things is written in Node, so we need to download Node dependencies. It happens. Another example is Nix can build Docker images. And you can define how many layers you want, and it runs a popularity contest to build optimized layers. So you can have smaller deploys, especially if you have several containers. And there's also Nixory, which is a custom Docker repository for built on Nix, which is super powerful. It's still fairly new, but I think it will be great. When it comes to Docker, there will also be a workshop tomorrow with Adam, who will speak more about Docker things and building Docker images. So I highly recommend that. Another example of great tooling from Nix is NixOps, which is for operations. So it integrates with different providers like AWS and certain providers like that to create infrastructure on the fly and then deploy a configuration. So it just creates the infrastructure needed and does things magically. And then you can change the configuration and it updates the machines running. Which is very cool, and I will love to learn more about that when Kim speaks later, after me. So I'm getting closer to the end here. I have some conclusions. Nix is a huge ecosystem for building and managing application. It has a proven track record and is here to stay. Basically, partly because its age. I mean, it's 17 years old. It's a lot older than people think. Many people hear Nix and like, oh, is that a new thing? No, not really. It has just grown immensely like the past 5 years, which is kind of why people are starting to pick it up now. And Nix is also very flexible and can be a good tool for users, developers, and operations. Kind of across the board, in my opinion. And I will leave some contact information up here. If anyone have any questions, you can ask it now. no questions.
About the Nixtor package hash.
Yeah.
Does it has anything to do with checksums of the files inside?
What did you repeat?
Like that hash of the Nix package, like in the store.
Yeah.
Does it has anything to do with the checksums of the files inside?
No.
No, it's like you can have different linear files inside, but the same hash of the Nix package.
For a non-deterministic build, yes. Because this hash is calculated before the files are put in the directory. Otherwise, it doesn't know where to put them. So this is based on the instructions. And if the build isn't deterministic, you will get a different output. We have a command you can run. I think it's nix build -- check and the attribute name, kind of something like among those lines. Then it will compare. It will make sure to download the file from the binary cache to have it, and then it will build it locally to see if it will get the same files in the output. But not all packages are reproducible, and there are people working on that, but it's a lot of things to do and a lot of moving parts, and I think there's also projects out there that simply doesn't care, and those are a bit harder to deal with.
Is there any marking like to differ non-reproducible like binaries from? Can you repeat the question for the three?
Is there any way of marking packages if they are not?
Can I recognize can I find like a list of the packages which are like can be reproduced with the same checksums which you can have?
It's a very hard. No, we don't have any way of seeing that because it's a very hard thing to get an overview of, because it takes a lot of build power to build it once and then build it again and then comparing it. But there is a guy running a project called r13y.com, I think it is, for reproducibility. And in periods, he rebuilds the entire small ISO package set to compare it to the binary cache to be able to see the difference for that set of packages. But that's just the small ISO, and even that has some bit to go. Any other questions? Yep, not.